Hello my dear students, in this lecture we are going to see basics of IC engine. Now first of all understand what is the meaning of IC engine. IC engine means internal combustion engine. IC stands for internal combustion engine. Internal combustion engine, right? Now here in case of IC engine there will be a piston cylinder mechanism. Let us say there is a cylinder. Here you will find one cylinder. It is a cylinder of IC engine, and inside this cylinder piston is reciprocating. Inside this cylinder the piston is reciprocating. Here you can say this is a piston which is reciprocating inside cylinder. The motion will be reciprocating, to and fro motion. Now the extreme positions of this piston are, here this will be the top extreme position of this piston, which is called top dead center, TDC, and there will be another extreme position for the reciprocation which is called bottom extreme position, or also called bottom dead center, BDC, right? Now let us understand this. Now if I draw this piston cylinder mechanism, here this is cylinder of IC engine inside which the piston is reciprocating from top dead center, TDC. TDC stands for top dead center, to the bottom dead center. Here there will be a bottom dead center. BDC stands for bottom dead center. Now between this top dead center and bottom dead center, piston is reciprocating, that is to and fro motion. Reciprocation means to and fro motion, and there is always clearance provided. Here this much space is called clearance. This space is called clearance in case of IC engine, right? Now in this clearance there will be a inlet wall. In this clearance there will be a inlet wall. Now IV stands for inlet wall. Now through this inlet wall air fuel mixture is taken in if it is SI engine. If it is SI engine, through this inlet wall air fuel mixture will be taken in during suction stroke. During suction stroke air fuel mixture is taken in if it is SI engine. SI engine is also called spark ignition engine, which is nothing but petrol engine. It is also called petrol engine, that is petrol is used as a fuel, and whenever petrol is used as a fuel it is called SI engine, and during SI engine air fuel mixture is taken in during suction stroke. This we are going to see in detail during SI engine, right? Again there will be a exhaust wall. Again there will be a exhaust wall. Here it is a exhaust wall. EV stands for exhaust wall. Now through this exhaust wall, after combustion the exhaust gases will come out. Now through this exhaust wall, after combustion exhaust gases, or we can say exhaust, will come out, right? And if it is CI engine, that is compression ignition engine, CI engine is compression ignition engine, then only air is taken in during suction stroke. Now for CI engine is also called diesel engine. Diesel is used as a fuel in compression ignition engine, and during suction stroke through inlet wall only air is taken in. But during exhaust stroke through exhaust wall always exhaust gases will flow out for both SI and CI engine. And there will be a again one device which is called spark plug or fuel injector. Here it is a spark plug. SP stands for spark plug, or it is a fuel injector. FI stands for fuel injector, right? Now if it is a SI engine or petrol engine, then there will be a spark plug. Then there will be a spark plug used, which is nothing but SP. And if it is CI engine, compression ignition engine, that is diesel is used as a working fuel, then fuel injector is used. fuel injector is used, right? And my dear students, this SI engine or petrol engine and CI engine or diesel engine, these engines we are going to see in detail in further lectures. Now, one more very important thing, remember that whenever piston moves from top dead center to bottom dead center or bottom dead center to top dead center, then it is considered as one stroke. That means whenever piston moves from any one dead center to other dead center, then it is considered as one stroke. Therefore, we can say whenever piston moves from top dead center to bottom dead center, then it is one stroke. It is considered as one stroke. Or if piston moves from bottom dead center to top dead center, it is considered as one stroke. It is considered as one stroke. Now let us understand engine geometry. Here you will find cylinder and piston is reciprocating inside cylinder between top dead center and bottom dead center, between these two extreme positions. Now here from head of engine to top dead center, this distance is clearance. This distance is clearance. And whenever piston moves from any one dead center to other dead center, it is considered as stroke. This is stroke of length L. L is a stroke. And let us consider the diameter of cylinder or diameter of piston is capital D. Capital D is diameter of cylinder or diameter of piston. Therefore, capital D is, it is also called bore diameter or simply bore, or it is a diameter of cylinder or diameter of piston. Diameter of cylinder or diameter of piston. And L is nothing but stroke. L is nothing but stroke. Now, the volume here in this clearance, the volume is called clearance volume VC. In this clearance, the volume is called clearance volume. And whenever piston moves from top dead center to bottom dead center or bottom dead center to top dead center, then it is considered as stroke, and the volume displaced by piston is called swept volume or displacement volume Vs, right? This volume is called, volume between top dead center and bottom dead center is called swept volume or displacement volume Vs, right? Therefore we can say here Vc is clearance volume. Vc is clearance volume, which is nothing but pi by 4d square, which is area into clearance. This much is a clearance volume, and Vs is called swept volume. Swept volume, or also called displacement volume. Also called displacement volume, which is nothing but swept volume is equal to, we can say pi by 4d square is area into stroke, right? This will be the swept volume or displacement volume. And my dear students, there is one definition called clearance ratio. Called clearance ratio. And this clearance ratio is represented by capital C. C is used to define clearance ratio. And this clearance ratio is nothing but ratio of clearance volume to the swept volume. Clearance ratio is nothing but ratio of clearance volume to the swept volume or displacement volume. And my dear students, this clearance volume is always provided inside piston cylinder assembly or inside engine. Here you can see this clearance volume is always provided. There are few reasons to provide this clearance volume. Let us understand these reasons. Right. Now, in this piston cylinder mechanism, in this clearance volume, here whenever piston is at top dead center, this volume is called clearance volume Vc. Now in this clearance volume, you will find there will be one inlet wall, there will be one inlet wall, there will be one exhaust wall, and there will be a spark plug. If it is SI engine or petrol engine, then there will be a spark plug, or if it is diesel engine or compression ignition engine, CI engine, then there will be a fuel injector. Now the reasons to provide this clearance volume. we are going to understand reasons for VC to provide this clearance volume one by one. There is a first reason that we need some space for opening of inlet wall and exit wall. Hence, clearance volume is provided. Therefore, first reason is space for, we can say, space for opening and closing of inlet wall and exhaust wall or exit wall, right? Now second reason is, now there is a spark plug, now for this spark plug will provide spark gap or spark, which will provide spark, and for spark we need sparking gap. Therefore we can say, for space for sparking gap, space for spark gap, spark gap. Whenever understanding SI engine, we will understand what is this spark gap, right? Now third reason is, now see, during combustion the temperature inside piston cylinder mechanism is very high. In this space temperature is very high. Because of this high temperature there will be a thermal expansion in this piston, right? This piston will expand thermally, right? And therefore for this thermal expansion we need space. Therefore third reason is space for thermal expansion, of piston. These are the three basic reasons because of which clearance volume is always provided inside engine. Now in case of IC engine, as there is a piston cylinder mechanism and inside cylinder piston is reciprocating, therefore there will be a crank and connecting rod also. Let us say there will be a cylinder. Now inside this cylinder piston is reciprocating, this piston is reciprocating inside this cylinder, therefore there will be a connecting rod, and this is a connecting rod CR, and there will be a crank also, here. This is a crank, right? Or we can say crank rod. Now here we can understand that this crank is rotating, like this. Because of this rotation of crank the connecting rod is oscillating. Because of this rotation of crank the connecting rod is oscillating and piston is reciprocating inside cylinder, now here there are four links, that is crank is number one link, connecting rod is another link, piston is another link, and cylinder is fourth link. Now in case of IC engine this cylinder is fixed, therefore this IC engine is an inversion of single slider crank mechanism. We can say IC engine is an inversion of single slider, because here piston is only one slider, here only piston is sliding inside cylinder. It is an inversion of single slider crank mechanism, right? And this mechanism you are going to understand in theory of machine subject, right? These all inversions you are going to understand in theory of machine subject. Now let us understand this. Let us say this crank radius is R. Here R is crank radius, we can say crank radius, right? And D is diameter of cylinder, capital D is diameter of cylinder or diameter of bore or diameter of piston. My dear students, there is no relation between crank radius and diameter of cylinder. These are different concepts. Crank is another device and cylinder or piston is another device. There is no relation. Otherwise many students write that D is equal to R. This is wrong. You cannot write like this, because D is diameter of cylinder and R is crank radius, not a cylinder radius. It is R is not a cylinder radius, right? Now, and this piston is reciprocating between top dead center and bottom dead center. Piston is reciprocating between top dead center and bottom dead center. Now let us understand this reciprocation, right? Now here I am diagrammatically we are going to understand these reciprocations. Let us say this piston is at top dead center, the piston is at top dead center, right? Whenever this piston is at top dead center, TDC, then definitely this connecting rod, here this connecting rod and crank, here I am drawing crank with red color, and crank will come in line, right? Here with black color there will be a connecting rod, this much is a connecting rod, and here this much is a crank, this much is a crank, right? And this crank is rotating, let us say this crank is rotating, right? Therefore at this position, whenever connection between crank and connecting rod is at this position, that is the piston will be at top dead center, TDC. This is a TDC position, right? Now, and this connecting rod is rotating, sorry, crank is rotating, this crank is rotating. Now during rotation, as this crank comes from this top extreme position to bottom extreme position, let us say at this position where the piston will come to the BDC, therefore this bottom extreme position will be for bottom dead center. Let us understand again diagrammatically. During rotation, let us say from this top dead center to bottom dead center, piston comes to the bottom dead center, right? Here let us say piston comes to the bottom dead center, and this distance is called stroke or stroke length, right? Now during rotation, the crank will connecting rod, now connecting rod will look like this, connecting rod will look like this, right? And here from this position, this total is connecting rod, this black color is connecting rod, understand carefully, this black color is connecting rod, and from this bottom position there will be a crank like this, where here the crank is pivoted, right? Here red color is crank, this red color is, we can say, crank, right? Now this crank is rotating, this crank is rotating like this, this crank is rotating like this. Now at this location, whenever connecting rod and crank are connected at bottom dead center, then piston will be at BDC. Now my dear students, that means whenever this crank comes from top dead center to bottom dead center, the distance covered will be 2r, the distance covered will be 2r, that is twice crank radius. Here you will find this much is r and this much is r, that is 2r. Then the displacement of piston will be stroke, then the displacement of piston will be stroke. Therefore simply we can say the stroke will be equal to 2r, that is stroke length is nothing but twice the crank radius, twice the crank radius. This is very important while solving numericals, this concept is very much important, right? Stroke length is equal to 2r. Now simply in another diagram you can understand like this. Let us understand again, let us say in same diagram, in one diagram I am explaining. Let us say this is a cylinder, and whenever crank is at piston is at top dead center, then there will be a connecting rod like this. After this connecting rod there will be a crank where it is pivoted, right? Now and this crank is rotating, this crank is rotating like this, right? Crank is rotating, means this is a top dead center position. Here this top dead center, here this position is top dead center. Now whenever this crank is rotating from top dead center to bottom dead center, here means during this rotation crank will achieve new positions like this, and it will come to this bottom dead center BDC. Then this piston will again come to the another extreme position, that is BDC. Means when this crank covers r plus r, this 2r distance, then this piston will cover stroke distance, which is nothing but L. Therefore we can say L is equal to 2r, that is stroke is equal to twice the crank radius. Now in exam generally it is given that there is a square ratio, that is for square ratio That means the crank length or crank or stroke, sorry, the stroke is equal to diameter of bore, that is diameter of cylinder. Stroke is equal to diameter of cylinder, which is nothing but 2r. This is a square ratio. And again they will mention for cylindrical ratio, for cylindrical ratio, this stroke is equal to 1.5 times d. Stroke is equal to 1.5 times d, which is nothing but 2 times crank radius, right? These are the two types of different ratios, that is one is square ratio and other is cylindrical ratio. Thank you dear students. In next lecture we are going to see engine material selection.